west of Ferndale, California, at 12.1 kilometers deep. It's a shallow quake. It's also in the Cascadia fault zone region, and what you have here is 3 plates, guys, and we've talked about this before. You see the red areas. Those are the actual fault zones because that's the breaking point. At one time, millions of years ago, the 2 plates to the left was 1 plate, but as they moved to the right and under the North American plate, under our west coast, it has forced the tip of that plate down and broke this section, just as if you were putting pressure on one end of something very fragile, then it would break somewhere, and that's what's happened. They're saying no tsunami warning, but this buoy, which is 150 nautical miles west of Mendocino Bay, California, it picked up a slight movement, and it came out of the initial shift with just a little bit higher wave, not much. And what you're looking at is the chart here, and this goes on the 4th through the 5th, the 6th, and up through the 8th. So everything's pretty normal, but we're going to look at it a little closer, and just to give you an idea of what you're looking at when you see these buoys. Water column height at station 46411, that's what we're talking about here. Notice your time. This chart is all today. It's in hour increments. And right there in the red line is where the quake was picked up by this buoy. Again, it wasn't a big shift because if you look at the bottom of this water column height chart on the left, you're dealing with 4,288 meters through the entire spectrum there. Now, this is just, it goes from 1,300 hours to 1,600 hours, a 3-hour chart. Right there, though, you notice that curve is a little higher coming off the backside. Again, we're just talking about less than 36 inches probably of total movement, but it did pick it up. Now, what's going on? We got a geomagnetic storm watch. Earth is entering into a stream of solar wind flowing from a large coronal hole, and it is very large. It's saying we're still in the outskirts. It could develop more today and tomorrow, but as we move into that, the solar wind speed is going to jump as high as 700 kilometers per second. Right now, if you notice in the top, we're 565 kilometers, so that's going to raise. And if your proton density increases there, which we're not sure about yet, that could put more pressure on our plates. But you're looking at current images of the sun, and the dark purple-blue area is a coronal hole. That's very large. It covers a tremendous amount of the sun, and guys, a lot of you know it, but I'll just repeat this. A coronal hole is not really a hole. What we're seeing is kind of like a clear sky on Earth. The other areas that are not blue are big magnetic loops. Energy is pushed off the sun and pulled back down. Now, where it's clear blue, there's nothing to pull it back down, so that solar stream is broadcasting straight from the sun towards our planet, and that's a coronal hole. I've heard people say, well, is it really a hole in the sun? No, it's a hole in the sun's basically magnetic canopy, guys. But we need to pay attention to that because you can see we could have an increase in wind speed beyond what we're seeing now from 750 up to 700 kilometers a second. That's fast. And that's a lot of wind because the size of the sun is so extremely large compared to our planet. But we're watching it, guys. Keep an eye on the top link on our website, bpearthwatch.com, because the earthquakes is the first one there. The second one, I think, is the images you're seeing on the right from the Solar Dynamics Observatory. And check out Space Weather because they give you a continuous account on the incoming rate or the incoming speed of the solar wind. And that's what the chart is on the left. Again, keep an eye on the West Coast. Watch for the earthquakes. If we have something stronger than this, check your tsunami warning.